Good evening, class. Today we'll be solving the past questions on some of the questions in physics, and we'll only take some out of it. Let's start. Number 1 says I, coherence, II, same frequency, III, same wavelength, IV, same intensity. Which of the conditions above are necessary to produce interference fringe? The question is telling us that on this, your I, coherence, II, same frequency, III, same wavelength, and IV, same intensity. Question is asking us which of these can be used to produce interference fringe. Now, what is an interference fringe? This is just talking about a wave. In this aspect, your answer are interference, same frequency, and same wavelength. Interference did not occur when there is the same intensity. Is that clear? What some of the properties of an interference is they are coherent. Is that clear? They are coherent. They also have the same frequency. Their frequency are the same, and their wavelength, or you say their amplitude, are the same. So therefore, our answer would be what? C, which is your I, your II, and your what? III. So these are the three properties of an interference. Is that clear? Now let's go to number 2. Number 2 says that a conductor of length 2 meter, a conductor of length 2 meter carries a current of 0.8 ampere while kept in a magnetic field of magnetic flux density of 0.5 Tesla. The maximum force acting on it is what? I'll check the question again. Said the conductor of length 2 meter carries a current of 0.8 amps while kept in a magnetic field of a magnetic flux density is 0.5 Tesla. The maximum force acting on it is what? Now, in this type of question, you are being given the length. The length of the wire is 2 meters. And you are being given the current that flows through the wire. The current which is I equals to 0.8 amps. You are also given the magnetic flux density in Tesla, which is 0.5 Tesla. So the question answered, you should find the force acting on it. The magnetic flux density is L, which is what? 0.5 Tesla. The question answered, you should calculate the force acting on it. Now, in this aspect, to calculate the force acting on this, you are going to get what is the formula for the force in a magnetic field. Now, the formula for this force is force equals to your magnetic field, magnetic flux density, multiplied by your current, multiplied by the length of the wire, which is, the abbreviation is force equals to what? B multiplied by what? L times what? I. Is that clear? Now, in this aspect now, we can get your value, which is this B. So your B is what? 0.5. Your L is what? Which is the length of the wire, which is 2. While your what? Your I is what? 0.8. In this aspect, we can decide. I don't want us to be using calculator much. We can change this to a fraction, isn't it? If you want to change this to a fraction, it gives us what? You are going to write the value divided by the, how many number after the point? 1. That means you are going to say 1 and 0. If it is 2 number after the point, you are going to write 1 and 2 zeros. Is that clear? So in this aspect, this one is over 10 multiplied by 2 times the 0.3 also. If you want to convert it to a fraction, you are going to write the value, which is 8, all over what is the number after the point. How many numbers do you have after the point? You only have 1. So you write 1 and 1 zeros. Is that clear? So in this aspect, we can cut. So 5 can go here 1, 5 can go here 2. 2 can go here 1, 2 can go here 1. You are left with 8 over 10, isn't it? 2 can still go in this one is what? 4. 2 can go here 5. Then you can now divide this by this. 4 divided by 5, what's it going to give? How many 4 can you see in this one? It cannot go. Then you write 0 point. Then you add the 0 to this 4. It becomes what? 40. 40 divided by 5 is what? 8. So your answer is what? 0.8 Newton. Newton is the unit of what? Of a force. Exactly. So Newton is the unit of a force. In some cases, a question might come like this, and they can decide to change. They can give us the force and tell us to find the magnetic flux. They can give us the force, the current, the magnetic flux density, and they will tell us to find the length. They are still going to use the same formula, which is force equals to magnetic flux density multiplied by the length and multiplied by the current. Is that clear? Now let's go to the third question. For the third question, is asking us that a cell of internal resistance is 0.1 ohms can be measured accurately using the A. Electroscope, B. Potentiometer, C. Ohmmeter, D. Meter bridge. I will take it again. The question says a cell of internal resistance is 0.01 ohms can be measured accurately using the A. electroscope, B, potentiometer, C, ohmmeter, D, ammeter. In this aspect, we are going to check what are the uses or what are the functions or uses of all these instruments. All the instruments being given. Then we will now know which one is our answer. Is that clear? Now, let's talk about electroscope. What is electroscope used for? Electroscope is an instrument we use to detect an electric charge. Is that clear? It is an instrument we use to detect electric charge. Which one again? The question says potentiometer. Potentiometer, what is the uses of potentiometer? Potentiometer is an instrument we use also to measure the voltage or potential difference between two ends or 2 points in a wire. You can also use it to measure the potential difference or the voltage between 2 points. Is that clear? It is very widely used and it is the most accurate instrument over voltmeter. Another one is voltmeter and potentiometer. Mostly both of them are used for just connections of 4 wires. So in this aspect, we have also ohmmeter. Ohmmeter is an instrument we use to measure our what? Our ohms. We use it to measure a resistance. So a resistance, when you want to measure a resistance, we use what we call ohmmeter. So out of these 4 being given, electroscope, potentiometer, ohmmeter, and what? The meter bridge. Which one is used to measure this? The resistance in a very accurate one. Which one? It is potentiometer. Potentiometer can be used to measure the cell resistance that will give it an accurate measurement. So the answer is what? Potentiometer. Okay. In this aspect, let's go to the last question. For the last question, a diagram is drawn to show a beam formation. You have a diagram like this. It's showing this is white, and you have 3 beams scattered. A, B, and what? C. The question has said, in the diagram above, a beam of white light travels from a red to a dense medium. What colors of letter do the ray A, B, and C respectively represent? I will take the question again. In the above diagram, a beam of white light travels from a red to a dense medium. What colors of light do the ray A and B, C represent respectively. In this aspect now, this concept of light is what we call a dispersion of white light. In a dispersion of white light, there are some colors that that will be dispersed, and they will follow from a lighter to a what? To a denser medium. So in this aspect, what this, your A will be red, your B will be yellow, orange, while your C will be what? Yellow. So the way they disperse from the red to the denser medium is from red to orange and to the last one, which is what? Yellow. Which means your A will be red, your B will be orange, while your C will be what? Will be yellow. So I think this is where we are going to stop.